everyone, we will solve this today's LeetCode problem. So the question is a split linked list in parts. So it's a medium one. Let's see what the question is asking. So we have given the head of a single linked list and integer k. Split the linked list into k consecutive linked list parts. The length of each part should be as equal as possible. No two parts should have a size differing by more than one. This may lead to some parts being null. The parts should be in the order of occurrence in the input list, and the parts occurring earlier should always have a size greater than or equal to parts occurring later. Return an array of size of k parts, right? So basically, it's just a math one, and it's an easy one, right? So many linked list problems you will find that it are not so much hard perspective to logic, but almost all linked list part is equals to it mainly are based on implementation basis, right? So in this question is easy, just you need to find that how many equal parts you need to just define it, right? So in this question you just need to split the given linked list into k parts, right? Into k parts, right? And if you are not able to equalize it, you just need to split it. You just need to split it in such a way that a first part a part is not a part size is not greater than more than one, right? A part size is not greater than more than one from other parts, right? From other parts, right? That's the question is given, right? So you just need to split this up. So if we see the first example in this case, or the second example in this case, this is given, right? This is a head and this is k. You need to split into three parts, right? Into three parts. So basically the size of linked list is 10. The size of linked list is 10, and you need to split in three parts. How will you do that, right? So you need to split in three, but still one is remaining. So if one is remaining, from where will you put that? So here is given that if size are not same, then you should always consider the first part greater than or equal to parts occurring later. So you need to just increase the first number by one part, right? Because difference should not be greater than one, right? So you should increase this by one. And suppose there are 11, so you need to increase this by 4. So you will start from the first part, then second part, then fourth part, if you want to increase the size, right? So this is just a mathematical part, right? So basically what will you do? The question is not very simple. Find you need to find the size of linked list, and then you need to just split it, split this size into k equally parts, right? Equally parts. And if so, what it would be happen? Suppose this is size, so you will split into equally parts. How will you divide it? K by times, right? So this will generate d times, but it can also be possible that it is not divisible, so the remainder would be left. So that would be size modulus k. And how will you distribute this remainder part? So you will start incrementing from the starting part, right? Suppose this is d, so this is you will start incrementing by d plus 1, d plus 1, d plus 1, till remainder is till remainder is not equals to 0, right? Remainder is not equals to 0, right? This is how you will just distribute it, right? This is how you will just distribute it, right? So the second part is, the first part is to find the size of linked list and just split it up. The second part, right? The second part is to distribute this node into list node, right? So how will you do that? So one thing is clear, that either you make a new linked list for each of the parts, or you just manipulate this the given linked list, change this given linked list and just assign something, right? So I will not take any extra spaces. I will use this given linked list itself, right? So I will use the given linked list, and I will not use extra space for creating list node, right? Creating vector of list node, array of list node, array of list node, right? So what I will do, I will just go to each and every part. It's just an implementation, right? How will you implement it? It's just an implementation part. Many you can the implementation can be different for you and different for us. If you understand the logic, this is just like an implementation problem, right? So how will you implement it? You will so if I take the same example here, so the division is equality distribution is 3, k divided the size divided by k, which is the 10 divided by 3, right? So this is equals to 3. Remainder would be remainder would be size modulus k, right, which is 10 modulus 3, which is equals to 1, right? So you can simply divide you can simply maintain 3 3 in order, right? So 1, then 2. So what would you store in list node? You don't store the whole 1 2 3. Don't store 1 2 3 and like that. You will just store the first head of each part, right? So what I mean that you will first store the one linked list, one node only in answer vector, right? In answer you will store only one. This will automatically move further and make this 1 2 3 4 in the answer vector, right? You will store the head node. You will store the first head node of each part, right? So the first head node will be 1, right? The second node would be, so the first this would be the size of 4, because this is the d, and the remainder is also 1, so d plus 1, which is 4. Now we don't have any remainder, right? So the next one will be 5, right? So this will be node in answer, right? And the size of will be 3. So after 3 5 6 7, then you will store 8, right? Node in answer, right? Which is again the size of 3, right? So that's how this can be formed, right? And it's just on your implementation how we'll implement it. So it can also be possible that the size, which is k, is greater than the size of head. So in that case you will assign empty, right? You will assign empty one, right? You don't assign anything, right? Now let's try to implement it. You will understand it better because this is an implementation problem, just right? So first thing is to find the size. So we will find the size, right? So the list node is temp. I will not iterate in head. I will just take an extra list node and initialize it with it. So we will iterate in temp, and the temp is equals to temp dot next, and I will increment the size. So this is how we find the length of size of linked list, right? Now what I need to do, I need to split it up. So size divided by k, remainder, which is size modulus k, right? So this is d and rem, right? D and rem. Now what we need to do, you need to make the array of k size, right? So we will make an list node of array of size of k, right? We will make that, right? Now I need to iterate in again this head part and store the head of each part, right? I will store the head of each part. So again I will use the temp and slice with head. Now I will iterate in this temp value, right? Now how we will find that, right? How we will find it? So I know the size, right? I know the length of the linked list. I know the answer vector. I know division. I know remainder, right? So one thing you see that I am storing only the head part, this one part. After the size calculation, right? After the size calculation I am storing only the head part, 1 then 5 then 8. How we will do that, right? How we will do that? So I need to take an extra length variable, which is 0, and calculate the length. How will you do that? Let's see. So the first part is extra part, right? The remainder is an extra part. So also I need to iterate in answer j, so that will be an index also to iterate in answer, right? So what I will do, I know that I need to store this answer, the temp variable, right? I need to store the head of the part. But so when will I do this? When will I do this? I will do this only when my length is 0. It means it is starting with the new part. If the length is 0, it means I am starting a new part, and that's why I'm storing the temp in that case. And this is j plus plus to store the next head, right? After storing, it will be j plus plus, so it will move to the next index, right? Now, when will this length will be 0, right? When will this length will be 0? So it will be 0 only when this size will be incremented, right? So I'm so this will be the same, right? Like this will be the same. That's why how this is calculation done. So we will increase this length. Also, I need to find the next node, the temp next value, right? I need to find the next node, right? Length is increases. So if now the extra point, right, the extra point is, if the remainder is greater than 0, it means this will return give me 1 or 0. If this is true, it will give me 1, otherwise it will give me 0. So how will I use it? I will use it like this: if length is equals to my d plus extra value, it means I got my first part size. I got my first part size. So if I got my first part size, it means I have completed the node. From next, no, from the next iteration, I need to store the new part head. So it will be length equals to 0 because I have achieved it. Also the remainder should be remainder should be used, remainder should be decreased, because in extra part I have used remainder now. For the first part I have used remainder, and when I achieve the first part size, I will maintain the length 0 and remainder also will be reduced it, right? Also I'm storing the temp, right? I'm storing the temp. So suppose I have stored the first, suppose I have stored the first part where it is, this is first part, and after the length of 4, 1 2 3 4, so the fourth next should be null. Otherwise, when the output will come, if you don't do for next null, so the when output will come, it will generate the whole linked list 1 2 3 4 5 6 7 8 9 10 whole, if you don't put 4 next to 0. So whenever, so that's why I have used next. I have not done like this. I have used next. Why I have done like this? Because if I achieved my length, so temp next must be equals to null. Otherwise, if it doesn't satisfied, I will just equals to temp equals to next value, because from the next part I need to move from the next head part, right? So this is just an implementation, how you implement it. I found it this way. Your implementation would be something else. I will suggest you, recommend you that you will implement by your own. Don't see this implementation, because your implementation would be something else, my implementation should be something else, right? So this is how this is work, right? This is how this work, right? So what is happening, I find the size, I have divided it in equally parts, I got the remainder, I have made an answer list node for storing the head of each part, and this is just an implementation. How will you implement it, right? So what I have done, I am storing I'm calculating the length for each part. So whenever I'm calculating the length, I also need to consider the remainder part from the starting till remainder is not equals to 0. So whenever the length of the part equals to d plus extra, I am just changing my temp next to null, because if I don't do this, it will print the whole linked list from where we have started. So suppose I have started from 1, it will print till 10 in the output. If I started from 5, it will print till 10 in output, which we don't want, right? So that's why I need to temp next to null and just change this temp to next, right? So this is how we implement it. Let's just run this. We have passed the sample case. Let's submit it. Yeah, bingo. We have successfully passed all the test cases. One follow-up question for you, right? Instead of initializing initially, if I do like this answer, I don't slice with k, I've just uh, slices without I've not fixed it, right? I've not fixed it. So I don't need this index, right? I don't need this index. So what I will do, I will just do this like this: answer dot pushback like this, push back temp, right? I will do like this, right? So what will happen in this case if I do like this? Will this be correct? No, it will not correct. When it will not correct? In this first part, when this k is equals to 5 and which is greater than the size of the linked list, right? So instead of this, if you run this, you will fail in first case because the k size is greater than the expected head of the length, right? So this needs to be empty, right? So if remainder is left, you need to iterate in remainder, right? But what will you insert in answer in array? What will insert in array so that you will get this empty array in output, right? Either you put null or something else. You will tell me this in comments, right? This is very a basic question, but I want you to think that what will you put in this. You will tell me in comments. This is a follow-up question for you. This is a follow-up question for you, right? Follow-up question for you, right? What will you put in this case if you don't fix the size, right? If you don't fix the size, I have not fixed the size, I'm just doing pushback because we can do this like this. But what will you put in this, right? So this is follow-up question for you. You will tell me in comments. So now the time complexity would be, so if you see uh, we are iterating in whole linked list, then again whole linked list. So that would be O of the size of linked list. Let's take n, and the space complexity. So we will not consider this answer array as an extra space because this is we need to return it. Otherwise, we are not using any extra spaces instead of this, right? So that would take O of 1. So this is how we solve this question, and yeah, this is how we solve this question basically. So yeah, hope you understand it. Thank you so much.